Welcome to part 4 of the machine design series with here at the West Michigan Lakeshore SolidWorks Users Group. I guess I didn't necessarily say who I was the first time, so we'll do that. Oh, that's the end. We'll do that. My name is Andrew Schutte, work at Smooth Logics, SolidWorks Junkie, all that kind of fun stuff. Jumping into SolidWorks here, we were talking about 2D details, and I'll finish this up just for posterity's sake, and then we'll get on to something else fun. I was starting a couple little rants about the proper way to do details, and the first one was to have your detail horizontal, because that's how you hold it in the machine, that's how you machine it in normal base case, almost always scenarios. Ordinates from the back or upper left-hand corner, left hand for you guys, because that's the side of your vise that doesn't move, and if you ever have a vise stop, it's almost always on the left-hand side of your vise stop because right-handed people are normal, left-handed people are weird. So that's kind of how that works. And in this instance, we have a whole call out. I must not have my normal settings loaded in here, so I'm going to override this and do what I would normally do. So if you didn't know, there's well, if you need to know more about this, you should go to the SolidWorks admin's presentations. But you can fully customize, so far as I've been able to find to the fullest extent, the SolidWorks whole callouts to pretty much anything that you want. So in this particular instance, I would do a quarter, yeah, okay. I would do 1/4 inch C-bore. And that's what I would prefer. In most cases, there's always exceptions, and for customers, we've done different things. But for most instances, that's what I'd like to see. Because anything, there's machinist handbook standards, and anything that's not to standard should be dimensioned out. If you give this to a machinist and they can't make a 2 x 1/4 inch counterbore, my opinion, you got other problems. So anybody else can throw in their opinion. If you don't like mine, that's fine. I enjoy the banter. I would also manage white space well, or better than this, so maybe we'll do 2:1 because those were kind of small. That's kind of big. In the world of AutoCAD, we try to stick to nominal numbers. In the world of SolidWorks, we can kind of do decimal places and everybody's happy. As long as we have good white space management, the details are clear enough to see, and it doesn't look crowded, but you're not undershowing your detail. So it looks like I need to do something like this, maybe, maybe not. Probably don't need that. General rule of thumb is the less number of details, the better. Rick says I do, and he probably wants me to dimension this because that's going to be quasi-critical. Oh yeah. So on this particular part, I probably do CNC to CAD because we're probably not going to make that by hand. No. For those that didn't hear it, Rick said if you're going to CNC it, then you don't need any dimensions, and that's not what I'm going to say in my presentation. If Rick wants to have his own presentation, he can say whatever he wants. In my presentation, dimensions are important. So yeah, maybe you do that right, and then maybe we're going to show a nice overall so that the person cutting stock can kind of figure out what stock to do. There's prevailing standards. I think ordinate dimensions to show stock size is fine. Some people like to see the traditional smart dimension, and they'll make sure there's at least 3 smart dimensions on their print to find stock size. I think that's a little overboard. If the person you're trusting to find, yeah, I don't do that. If the person you're trusting to find your stock and cut it can't figure out an ordinate dimension, again, kind of like the machinist thing, you might have other problems. So a print like this, obviously missing material, missing description, that kind of stuff. But as far as the construction of the print, doing it here in the last 5 minutes and just glancing at it, we'll add a note for sure, right? CNC to CAD data. Right, you've got that. I might copy the note and paste it over here to just be clear about what we're asking them to cut. Right, but generally at a rough glance, this appears to be a completed detail minus the metadata. I don't know if anybody has objection to that. It is, you're right. Yes and no. My fear is that if you look at this, it might, well, the ISO helps. Yeah, I could go either way on that, but I'll take it off. Make Paul happy. All right.
Tolerances matter.
I'm sorry?
Tolerances matter.
Yeah, and I don't disagree. In this particular instance, because my friend Jerry isn't sitting here, I'm not quite sure how tight they're doing it. That one dimension there, right? Maybe this particular dimension here would be the only thing that's reasonably toleranced, give or take. So let's say it's plus or minus a thou. I don't know. Right? That's something that's practical because that's the one part crowding it. The what?
You don't want to go plus or minus a number.
Why not?
You should always go for the number and always either plus tolerance or minus tolerance. You go for the main number and then you're overshooting the tolerance the more.
In my machining days, whether it's a number plus, a number minus, or a plus or minus, you always machined for the mean and just shot for the middle. So if this said 1003 plus 2, I would still aim for 1004. I'd always machine right for the middle in my machining days. And in this particular instance, right, you'd go small on the first pass, but you clean it up on the next pass, aiming for the middle. Yeah, it depends on what you're trying to accomplish. If I think that was 10 thousandths clearance on each side, if I remember the fixture from last time, and I want a minimum of 10 thou, a maximum of 14 thou, then yeah, you'd plus 2. If I want 10 thou, but 5 would be acceptable. It all depends on what you're trying to accomplish from a manufacturing and design standpoint. Rick's not wrong, but because it's my presentation, I'm going to say that's okay. All right, over here we had to do something. I think Jerry said they're driving that screw. I think we did that block already last time. I think we had to hold the pipes, hold the bracket. Oh, we needed a staple clamp here. That's what it was. All right, so because this particular block is the way that it is, it would make a natural bolting area for a destaco clamp. So let me rotate this part here and save and get out of it. So for those of you that aren't aware, there's two different ways to open a component in SOLIDWORKS from the graphics view or the feature tree. Because I'm not super familiar with this component because I drew it 3 months ago, and because the orientation of the part is important to me, when I click open, we're all familiar with the far right hand or the far left hand open side. 1 over is open part in position. The in position is pretty cool. When you open it, it'll open the part and then it'll rotate the part to be in the same position as it was in the assembly. So I know this is the face that I need to elongate. If I wasn't super familiar with that part or didn't exactly know what was going on, I may not necessarily know that. So instead of trying to figure out what dimension to change and how my design intent is, let's say I took this design over from one of you guys, right? Instead of trying to figure out what dimension to change, what the design intent is, what the external references are, based on what I change, what's going to blow up, et cetera, et cetera, et cetera, the cheater way of doing it, which in machine design, there's a lot of cheater ways that are perfectly acceptable. If this was product design, I would write somebody up for this. But I'm just going to click Move Face and make sure my parameters are set to that edge, and then maybe say 2 inches. I did that right? I did not do that right. What did I not do right? Oh, I picked a face. Let's try picking an edge. Nope. Let's try picking. I did pick the right edge. Whatever. Let's just move it this way. So in SOLIDWORKS, you can kind of pick on any face you want, and you can move, rotate, translate, a few other things. So let's just say that's 2.5 inches. Now the reason I did it this way, and the reason why I say it's cheaters, because from a design intent standpoint, that's really poor. But whenever I made that block, I got an error. Where'd that error come from? What's an error about this? I think that block might have moved or something. Why is that erroring? Did I change something on that? Did I not save? Did I deleted my dowels? I don't remember doing that. The video will tell us. All right, well, you all saw me do it, so we'll just pretend that it's done. Okay. So if I knew I needed a destaco clamp on this originally, I should have made that block longer originally and done it more intentionally. Because I didn't, or pretend it's a takeover design or something like that, I now just want to take this destaco clamp, holding down the control key, I can drag a new instance of it in my graphics view, pick on my select other, grab the base, make that in place, move this around, right click to drag to rotate, move it about to where I want. Looks good. Right click, drag a little bit more. Hopefully I can mate that up. Whoa, look at there. Mate that up to that edge. Wow.
So since most of us weren't here on your first presentation.
Yes, sir.
What is your preferred method for orientating the block to start with?
This block?
Yes.
So I don't know because I don't remember what I did verbatim. So I'm going to think through what I would probably answer and we'll see if it's correct. So this block we rotated to make sure we only had the single compound or the single angle, not a double compound angle. This block, what I'm guessing I did, and because I just broke my assemblies in the beginning, let's edit this and try to figure it out. What I'm guessing I did is I made a sketch triad in 3D space, and then I said that it is parallel to the plane. Okay, so I knew I needed a hole so I can put an alignment pin in here. I'm trying to figure out how to explain it without breaking things. Okay, I'll try to explain it this way. Get rid of that part, get rid of that assembly. So this hole is at an unnatural angle to this plate. And so I need to rotate my block in a way that I only have one angle, which is desired. And you can do that by creating a sketch. I'm just going to delete that. Okay, so that's what it was. So if you create a 3D, so this is the key, a 3D sketch. I see a lot of planes and a lot of axes, which is an acceptable way to do it. I find them very kludgy and messy and not very, they're hard as a user to control and do what you want dynamically. They're not dynamic features. I really like 3D sketches, and thinking back through here and looking at what I'm doing, looking at what I did, this is what I did. So I made a 3D sketch, and this line here is concentric to that hole, and then I put a triad on here, and all I want is the bottom of this triad to touch that plate, so I can click on that plate, click on the center point of that triad, and then there's an on-plane relation, which if you've never played in the 3D space, you may have never seen. But imagine just a line in 3D space trying to touch a table or something, and there's an on-plane. Coincident doesn't work because coincident is only on a projected view. If I'm drawing a 2D sketch on this face, I can coincident to an edge. But you can't coincident on a non-projected view. So on-plane basically is your pierce point. Where does this sketch go until it hits something? That's an on-plane relation. So let's try to exaggerate this a minute. Let's pull this up. So if I click on that and click on my plate and say on plane, that triad sketch is going to drop down until it hits that plane. Now I can take any one of these members. I'm going to guess this one. If I change this too much, things are going to blow up, which would be fun. And then click on my plate. If I do a parallel, so again, in a 3D sketch mode, we've got some other non-typical relations that you may not be exposed to, but there's make normal, which is basically perpendicular. There's an actual perpendicular, which ironically enough is different than normal, because normal is perpendicular in two axes. Perpendicular is going to only be perpendicular on one axis. So this is a perpendicular line to the table. Sorry for everyone on the internet who can't see my hand. And it could still be perpendicular like this, because from here to here is perpendicular. Normal is going to be directly opposed from that surface. And then there's on, or make on plane again, make parallel to X or Y, make parallel to Y, Z, or ZX planes. So in this instance, I think I want parallel. You can see that triad move until this line is parallel or otherwise touching, or it would be on plane would be another way to do it. I find the parallel relation to be more robust. So then basically this triad has rotated to the point where if I put a block there, I know that I only have a single angle that I have to construct. So if I didn't blow up anything too badly, we show our block again, I'm assuming that we're going to see the block constrained. So you can see how I used the center origin of the block because all good designers design their parts center origin base feature. So the origin of that block, let's see here. So the origin of that block is basically at the origin of that triad where that 3D sketch from that hole touches the plate. Does that make sense? That's part of the reason why I didn't extend face, because I didn't remember all of that, but I assumed there was something important about where the origin was and the good design intent that I just wanted to stretch that face out and not necessarily worry too much about what I had done or breaking it. And it's been a really interesting experience for me doing these 2 hours, 3 months apart. It's almost like Rick just gave me his design because I don't remember what I did 3 months ago, much less in the 2 hours I tried to cram through this kind of stuff. So this has been really fun for me. Hopefully you guys like it. And you'll kind of see that I still have a lot of those sketches turned on. So I did do an axis here just because I needed a single line down the center of that tube. So that makes sense. 3D sketch does not. But then over here, it's going to be the same thing. I wanted to make a single angle on this part and make it against that plane so that we could put the part on there. So I just drew a triad 3D sketch centered of that tube, rotated this till it was parallel. And this is a lot easier to see, right? We can see if we measure that these are parallel. And so as long as you can orientate your part perpendicular to that parallel edge, it makes for much more simplistic machining and a lot simple setup, because instead of planes and axes and multiple stuff, that's all compounded and I think not flexible and pretty kludgy. This works really well. So I don't know if that answers your question or...
Yeah.
Any other questions?
Trying to get to the point of design intent.
Good question, Todd.
I got it.
Is that how you would have done it?
Similar.
Okay, sweet.
Probably, I use planes a lot for orientating it.
I like planes when there's no other option. or like in this instance, it's a reference plane, right? Because I want to work down to this plane level, so that makes sense if it's transcending parts and stuff like that. But yeah, anyway.
Yeah, I worked off the center of the part.
Good man. Your first extrude should almost always be a mid-plane. All right, so it looks like I need a little bit more over here. So I don't remember if this trick works or not, but let's try it. I want to extend this face over. Yes, I'm being sloppy. Let's constrain that. In that instance, a coincident would work. This is going to be 2 inches, let's just say. And under features, under curves, there's a split face. I think I can split that face. Now, is it going to let me move that face? I don't remember if this works or works in a certain other instance. Where'd my triad go? Nope, does not work. All right, no problem. So I don't remember if this is normal enough to do. It should, if it's simple. So I should just be able to convert these two entities, convert that one, flip the inversion on these, draw a vertical entity, connect those up. Merge, not coincident, that's always fun. And in this instance, what's important to me is the distance from here to here. I'm trying to meet that clamp. So I don't know if 3 inches is good, but we'll say we'll extrude that this way. 2 inches, I think, was the number there. Good enough. Where am I working? Here? Yeah. All right, so the clamp base is roughly 2.5, so we'll do, that looks good. So put in holes, I think we've all seen holes. I could probably have run that extrude all the way or just done a face because I don't know that that room is going to be at a premium. So if you just double click on a face on a extrude create or an extrude edit, it'll change that extrude end condition to up to face. So it's a really easy way to just double click. The face turns pink that you double clicked, the feature changes to up to face, and then you can just right click to rebuild. Kind of a fun way to quickly power through that. So put in mounting holes again. In this instance, because I don't perceive there to be any interference, I would have to do holes at some point before I give the design off to manufacturing. But in the scope of what I'm trying to do today to see if the design fits to get to a design review state. Because when you're designing like this, assuming you work in most normal environments as I do, you have to get to design review state first. Your boss or your customer or somebody reviews it, signs off on it, yes, that's a good design. yes, the staple clamps work. Yes, SMC is an approved, pneumatics for this vendor, whatever it might be. Then you go back and add all the detail. Adding holes now would probably be, there's probably no way in which I would save time, because if I add holes now or later, it's the same time, but there's a higher chance I'm gonna lose time because, the two constant rules in design is everything changes and everything breaks. So there's no reward and only risks to add the holes now. So that's why I would not add the holes now. I'm sorry?
Is that why SolidWorks crashes?
Can't answer that.
Do they have to meet the rule?
Oh, because everything changes and everything breaks?
Yeah.
No. Looks like I didn't finish this part. We should do that. That would be fun. So it looks like I need to relieve this a little bit more because there's this ring around there. I'm just not ADD, although I am a little bit, but constantly while looking at things, I always look for interferences, right? SolidWorks does a really good job at showing you a soft line or a soft edge. So a hard edge has these black lines on them. And so anytime you see a hard edge, you know that you're seeing the abrupt edge or a tangent edge or something like that from your design. So I just noticed that this is a soft edge where you don't see a hard black line. You just see the melding of two colors. So that's going to tell me that we have geometry interferences. And there are evaluate tools that you can do that. There's clearance verification. This is probably going to take a long time to run or maybe crash, right? Who knows? So I have to select the entire thing. So this is kind of where the automatic tools in SolidWorks are frustrating. Okay, you surely should have detected a clearance. A, they don't work very well evidently, or I don't know how to use them. But B, if you don't know exactly what things you're trying to check between. Okay, now it worked. Oh, but it's finding interference on itself. That's not helpful.
Well, there's some settings.
Yeah, obviously I don't use this very often. I've never found it to be terribly helpful. Maybe if I was better educated on it, I would find it helpful. But it's the same thing with like the whole alignment tool. I just don't find them helpful.
It is very helpful, but there's settings down farther that you gotta, the right ones to
Okay.
show what you want.
In a multi-body part instance, I do a lot of that kind of stuff from a Boolean operation. In the assembly, I don't know if I just gotten lucky or I spend too much time looking at my designs and I just catch them myself. But in this instance, right, I noticed from a soft edge to a hard edge standpoint where the green and the gray are melding, that's a problem. So it looks like I did a relief here. I don't know if I didn't define it, and hey, look, I didn't define it, and the relief moved or something. So let's figure out this. Let's move it over here. And again, if this seems unscientific, it is. Sometimes it's not specific enough to matter, right? Like as long as we're holding the tube up here and holding the tube down there, whether I remove an inch, an eighth of an inch, or half of an inch, nobody cares. So spend the time and add specific details and accuracy when it's important, and when it's not important, just don't spend the time. Part of the concepts of a well-seasoned and good designer is knowing what to spend the value add time on, and then what to skip over and not waste the time on. So that's certainly my clearance rate. I could easily adjust that and clean it up, and I probably would when I get to the detail side. But again, from a design review standpoint, this is now design review ready, where I could show somebody and maybe my customer or my boss is gonna freak out that I have a sharp edge here and they could, catch the tube on. So maybe I have to fix that sharp edge. So maybe I would, and again, I opened up in position so I can find that easily. So maybe I would move this cut above the fillets, edit that fillet, and see if I can't fillet that edge as well, to soften that edge, to go back to SolidWorks, assembly, and maybe that looks better now. Whatever, who knows? Maybe I should radius the edge up there, but you're not going to be able to get a ball cutter in, so you're going to have some problem there. But that's the concept. So you've got the staple clamp holes. Looks like we can still get a screw gun in there, although it depends on where the operator is. Is the operator on this side? Looks like it. So at least the screw is forward of the operator from the staple clamp. Otherwise, you might need to do low profile clamp or a clamp from the other direction or something to gain access to that screw. So not only think about the machinability of it, how is the operator going to use it, and how friendly would that be? Pretend we need to put another staple clamp on there, but it's pretty much the same as that, and you all saw me do that already. I'm guessing that's a alignment pin, and we need a staple clamp here. You saw me do that already. So I don't know, I can make more 2D drawings. We could add a pneumatic cylinder and just make something up. What do you guys want me to do? Show the clamps open. You had to say that. So when I downloaded this as a parasolid, it just dumped it as a bunch of parts. I made the parts virtual, so they're all embedded into the assembly. But this is just a fixed blob right now. So now Radar wants me to make it an unfixed blob. So this will kind of be fun. You first have to identify the components that you need to unfix. So those first 4, handily enough, don't need to move, neither does that one. So I'm going to put those in a folder called base. All right, what's next? So that should move, that should move, that should move. Those should move together. And then here's the other thing, like I hover over here. I don't know what that is. It's something in the middle. I'm guessing one of those rivets or something. I don't care. So I'm just going to delete it. It's a virtual part. It's gone. Oh, wrong part. I don't care. It's a virtual part. Delete it, and it's gone. I'm not going to spend the time. Unless your designs are so big that extra detail on a staple clamp is going to radically slow down your computer, I don't necessarily need to spend the time to clean this up or make it better. But if I do have to spend the time and clean and show kinematic motion or do something, then I don't want to spend time on unnecessary geometry that's going to serve me no value. So that's why I didn't bother cleaning up or deleting anything before and why I am now. All right, so we've got these components that all I think need to move together. Oh, not the last one. Just those. It looks like I got a couple pins that I could include. So again, I'm just hovering over and seeing the graphics previews to see, what are those little washers? That's frustrating. Do we care about those? Nope. Okay, so we got handle, 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 pin, bushing or something, not sure. This is the problem with imports, right? Is that there's no particular rhyme or reason. Okay, I think that looks good. So that's the handle group. And then I think that's going to be the link group. Okay, all of this is fine. Again, I'm not sure. I think that's a bushing or something down there. I'll just delete it later. Not sure what that is. Delete that later. And that. Okay. So this is the arm group. And these two things we're just going to delete because I don't know what they are. Not serving me value. So now that I have these groups, I'm going to unfix them one at a time. So floats, shift select them again, and mates. And in advanced mates, nope. In standard mates, yep, you can do a lock mate. And basically, you can lock all of these together. Come on, SolidWorks. Let's try that again. Shift select, mate. Well, that's irritating. Seems like I've done that before. Okay, let's try it a different way. Pick them in the graphics view. Maybe that's faster. Well, let me pick 2. What have I've done this before. Okay, new idea. We're gonna shift select and say form new subassembly. And new subassembly is gonna be called arm. And we're deleting the folder. Another good instance for the use of virtual components. I created a subassembly, didn't create a file on the hard disk, didn't care. We're gonna create a new subassembly again. Yeah. Calling this link. Deleting the link folder. Create a new subassembly for handle. Again, just selecting on it and F2 will do a rename. Handle. Delete the folder again. I don't really care about this. I don't need to create a subassembly. It's just all fixed. It's the base. It's fine, whatever. So now I should be able to drag these subassemblies around, and I only have to make the mates of the subassemblies that I care about. I don't have to mate every single component. Now, obviously, if you open up the assembly and start dragging stuff around, things would be bad, but they're all fixed inside of their relative subassembly, so I'm not too worried about it. So let's just undo these so I know how to mate them up. So let's grab that and do a concentric. And then let's grab this and that and do a concentric. Let's grab that and do a concentric. And then let's grab this and that and do a concentric. Now we should be able to see they're all working together. Good. So now let's see if I can find a center plane like that. Let's see if I can run a multi-mate on the center plane. See if I can, by random luck, my assemblies should be created at the same origin of the collection of parts. So the same front plane per subassembly, most of the time, if done what I did, should work. So with a relatively minimal amount of work, it's the smallest amount of work I know of how to get there. I don't know if anybody else has a better way. Now there's cleaner ways to do this, right? You could round trip this spare solid, make a few parts instead of virtualized subassemblies that have other parts that are fixed. So if this was a Destego clamp that you're trying to use for the next 30 years and lots of jobs, I would definitely take more time to clean this up. I'd get rid of the text. I would vastly simplify this. For my one-off fixture machine design and get it out the door, because I can't justify an hour of cleanup if I'm not going to use it in multiple projects for the next 30 years, right? So your profit value, your cost of opportunity and return on investment differ greatly based on your industry. So if any of you are from FOG and say, oh, this would never work at FOG, I agree with you. FOG has different policies, so on and so forth. But this works really well. The subassemblies, the common concentric mate. Notice I have a multi-mate here, which has the one plane of my base assembly with the 3 other planes. So your multi-mates are helpful for cleaning up your mate tree and speeding up SolidWorks. Because SolidWorks only has to find that one common reference, and it matches these 3 common references up to the 1. If you did 3 individual mates, it has to find one reference mate, the same reference mate again. So it saves CPU cycles in that context. Now, as far as constraining this goes, there's a couple ways that you could do it. Doing an angle mate on here is probably going to be the most robust. So maybe I want to take this edge, take that face, and mate it down. Excuse me. Whoops, I did not mean to do that. Pretend I didn't do that. So let's take this edge, take that face. Instead of hitting my quick mate, which is what I did out of habit, hit the M key, or my keyboard shortcut is M key instead, but you can also click on the mate symbol. Down below, there's an option here called Use Mate for Positioning Only. Any ideas what that does? Positions it, and it does not? No mate. So the helpful thing about that is there's no mate in the feature tree to go delete, which is what I just did. But it will accurately position it exactly as a mate. So it's in the same spot. That doesn't constrain it, I can just move it back again. But it gets it in the right spot. So now I can pick my top plane, or maybe the bottom of my base or the top of my base, pick this edge and do an angle mate and just accept the angle mate, because I don't have to figure out what the angle should be or change the angle mate every thousandths until it touches or does whatever. So that would be my closed mate position. And then I could, so let's save this to closed. Let's do another one of open. And then let's say I want it open. So let's suppress this. I'm on my open configuration. Yep. So let's suppress that closed mate. Go like this. Forget in Destego clamp world what limits it. Oh, it's this on this. It's that, right? Yeah. So that's going to be a little bit hard, and we don't really care. It's not that accurate. So we'll just move it till we see a little bit of interference.
That's just an upset on the nose.
Yeah, I think that's just the stamp out of, because they're not as precise about their open. So again, another angle mate, just accept it as fine. I always like to rename my mates, closed, open. If they're configuration specific, I would right click on them and do configure feature. Make sure my suppression is working appropriately. The suppressed mate, the open mate is suppressed on closed. The closed mate is suppressed on open, as it should be. So now, as I toggle between them, we should see our Destego clamp work accordingly. Save and close. And then I should be able to, with breadcrumbs, pick this. Oh, I think they fixed that in 2019, but it doesn't work here. All right, what is it complaining about now? That is not happy for some reason. No problem. Let's find out. Here is that plane. Here is that plane. Coincidence. Good enough. So that may blow up now, I'm not sure. We'd have to constrain it differently. If I click this and do open and green check, I've now simulated that open here inside of the assembly. Part looks like it's clear to come out, no problem at all. Same thing here, we can just do an open, green check. No problem, maybe a problem. Should be able to lift it up and over. I think these clamps are probably twice the size they need to be for the application. But yeah, you could modify that clamp a little bit in orientation or in size to fit that application a little bit better if you really wanted to. Does that work? I don't know. From a imported parasolid with a bunch of parts to making it work, that seems like that's the easiest way I found to do it, if anybody has a different idea or a better idea. Now, it's not necessarily the cleanest, and if you're going to use that as a library model for the next 20 years, I would definitely encourage you to invest an hour of time to clean that up. Are you 6/116, Paul? So, you would clean that up. Would you get rid of the text?
Yeah.
Good man, that's why you're on the team. Right answer.
Probably leave that to the campus for that.
What?
It's small enough.
Okay. No. Yeah, look at the number of triangles in that. Come on. By the way, a really great way to visualize the number of triangles. Does everybody understand the triangle count? We've got 15 minutes left. When do we start? 7? Yeah. Everybody understands the aspect of triangle counts in graphics view generation, right? Okay, so I believe this to be a true statement, all CAD software in the world uses triangles to calculate geometry, because you take 3 points in random space and you put a face between them, and you can do that enough in small enough pieces and you kind of get the right result. The way to see how SOLIDWORKS generates stuff is you go to Document Properties, under Image Properties, Image Quality, and turn them down, like way down. You kind of see that you get this octagonal hole, if that's a word. And because you've got, everything is a triangle, right? So you might have, well, this would be 4 triangles because there's a split there for some odd reason. But you would see that there's 2 triangles nested here, and 2 triangles, and 2 triangles, and 2 triangles. So if you take your graphics performance and you crank them up, which evidently mine was pretty high, I don't know why it was that high. Document, and then image quality, and we crank this up to the sweet spot, and say, okay, SOLIDWORKS will regenerate, and you can kind of still see there's a little bit, but it's a much improved. The easiest way to that I've found so far to visualize what the triangle count looks like and effects from a graphics quality side is if you do a save as, dump it to the desktop as an STL, and under STL options, there's coarse, fine, and custom. So let's just do a coarse STL example and hit save. STL is for 3D printing. Did not mean to do that, but okay. Desktop, all files. Nope, can't open a movie file. Let's try that again. Desktop. Did it not? There it is. So this is an STL, and this is how the triangles look. So you can see here in trying to generate that hole, there's 2 triangles here nested with each other. And this is how the graphics engine is actually processing the graphics in real time in SOLIDWORKS. So you can see how a flat block, which has 6 flat sides, would have 12 triangles total. If you put a fillet on one of those sides, your triangle count goes from 12 to like 300, right? The more fillets, the more complexity. So the STL is a really fantastic way to visualize the triangle count. And you can see here at this text that Paul and I were banting about, you can kind of see the triangle count. And this is a coarse STL export, right? So you can kind of see the triangle count here. What that should be just a couple flats. So going back to SolidWorks, the other part here. Yep. You can, but that doesn't show you the triangles. I like to visually see the triangles, but you're correct that the triangle count does give you a count. You are not wrong. So let's do another one, and let's do a fine. Actually, I was at a customer in California last week, and the fine STL export in SolidWorks settings wasn't fine enough for their 3D printers, because they had high enough end 3D printers and specific enough details that they needed something more than the SolidWorks defined to default of fine for STL export to get a successful print. So they're going in there and cranking up the settings even more. But this is what SolidWorks considers fine. Fine being like precise, not fine like it's okay. And you can kind of see where some of this just looks like solid, because as you zoom in, you've got that level of triangle count. And you can kind of see here where they're all coming, because you've got that focal point in your text circle there, the O. And this doesn't rotate worth a crap, but you can kind of see how the triangles are working. So as you crank up your system settings, I mean, especially a feature like this, right? Now I'll add a few fillets just because that's going to be fun to do. So let's just fillet, nope, not that side. Stop. Should not have clicked on that. If I knew I saved everything, I would just force close and reopen. Any other questions? All right, we're back. So let's pick on this. Do an 1/8 inch for fun, and then let's do a fillet on this. Because fillets around holes, those are super good. Meant that to be different. Let's do that just so we have a little edge there. All right, now let's save this off to our desktop as another STL. And let's change our options from fine to custom. Let's really crank that baby up. Deviation is super small. Whoa, look at that preview. Who's excited to open this up? All right. So this is what it looks like when you turn your system settings on max. Your graphics card is processing every one of these triangles as you're opening and rotating and messing with your model. There's so many triangles and lines there, it looks like a solid edge. But as you zoom in, you can kind of see, right? So these triangles are going total lengthwise around that fillet. And then these hole fillets here are even worse. Look at that. So this is what I was trying to find from a triangle standpoint. This is a really good example of triangle mesh. So those 3 points are just ever so small or ever tighter together to get the triangle surface so much smaller. And with more triangles, you get a more specific and precise appearance. Now the file size of these is going to be interesting, not the video. That's the original course one is 50 kilobytes. So you can fit like, what, several hundred of those on a floppy drive, right? Nothing. The fine one is 100 kilobytes, so twice the size. The super fine is 24 megs. So you went from hundreds on a flash drive, whatever, a lot less, about half as many because it's about twice the file size, to 24 megs. You need, was that a dozen, or not flash drives, floppy disks, right? Your 3.5 inch floppy disks, right? 24 megs is huge from a 3D print file standpoint. But if you need the precision and you have the printer to do it, that's how you do it. Now, a lot of the printers are really good. They're doing post-processing like in SolidWorks itself, so it saves you the STL round trip file. But you can see the number of triangles. And that's what 3D CAD is trying to do all the time based on your system settings. And that's why if you have this text in here, it might seem like it's not a big deal, but that text has all of those triangles built into it all of the time in back of the graphics engine. And especially if you, like, it'd be really bad if you had a 16 position dial you had 3 or 4 of these in every station, and you circular pattern that, right? Your graphics GPU hit went up a magnitude of effort. But in my simple design, if you've got 3 or 4 and you're not patterning anything, I probably won't notice a discernible difference. For those of you that care, an easy way to clean this up is, well, the easiest way to clean this up is just to draw a box over it, extrude it out to the other side. Why? Is it because it's a surface? But I was filleting the surface. All right, fine. So if it's a surface, we'll go to surfaces, trim surface, and under standard, there's my trim. We're gonna keep that. Haha. And now I can click on that and hit the delete the hole. Here's the sneak peek, or here's the pro tip. If you pick, so same thing like we're talking about hard edges and soft edges. In SolidWorks, if you're doing surfacing, a blue hard edge is the edge of a surface, and a black hard edge is the edge of a knit surface or a solid. So this instance is a blue edge, and what you can do anytime you see a blue edge, oftentimes when you see a blue edge, always if you see a blue edge that's encompassed by a single face, you can always click on that blue edge and just hit the delete key, and it'll ask if you want to delete the feature or delete the whole bracket holes. The funny thing is that doesn't give you an option to pick holes, it just gives you an option to pick one hole. So a lot of times I see a feature tree filled with hole deletes because you just pick a hole and delete, pick a hole and delete. If you go back and you edit the delete hole, it'll actually let you pick more than one. It's a super secret trick that isn't well known. What?
I did not know that.
Yeah, see, there you go. Todd learned something. Mission account. Yeah, and you have a feature tree full of them, don't you? If there's a lot of holes.
I don't usually have to delete that many, but
Okay.
I use that feature all the time.
Yep, but you can go back and edit it, and you can pick as many as you want. As long as it'll build one, it'll build all of them. So that's how I would delete out those there. Now I've probably broken it. Well, maybe not. I might have not broken enough things that the assembly still works. No, I don't want to save it. Go away. So a slight jump, rabbit trail off machine design, but that's what you need to know about triangles. Yeah, I think I broke a few things, and this is no longer working. So we'll just perhaps, this side I think. We'll just delete all those features in a minute. It's still angry, but okay. I don't know if my configurations are going to work anymore, I guess. Yeah, they do. All right, we'll figure out what's wrong with it. Oh, it's just that one part has an error. The mates are fine. Okay, no problem. So that's that. I wanted to do one more quick detail. I think I got 5 minutes. Maybe we can figure this out. So I want to make a detail of this. We'll just pretend those 2 holes is all we need. And click on my handy dandy drawing button because I added that to my toolbar. So let's grab this, rotate it 90 degrees, actually 70 degrees. Because again, if my vice stop is on the left-hand side, I want any side milling or anything that has to be done on the right-hand side. So let's say I set this up, no problem. Let's throw on some Tolkien dimensions. Let's say that, right, let's say we've got this, no problem. Now we all know that we can do an auxiliary view off an edge, which is going to be on an angle. But now how do I dimension those holes? That's always the problem. The people who don't know any better dimension off a virtual edge, and then they say, what do you mean, machinist? Why can't you use an edge finder to pick that up? That seems perfectly logical. It worked in CAD. If I couldn't put an ordinate on it in CAD, then, or if I can put an ordinate on in CAD, then surely you can make it. Right? Who among you thinks this is an acceptable way to detail those holes? Good, I did not see a single hand. How would you detail those holes? What would be an acceptable way? Construction hole. Thank you very much, gentlemen. I appreciate you being in here. So let's set up a construction hole. This is my, my own little preferential twist on a construction hole. Let's do clearance holes, because we don't need them to be press blind is fine, double diameter plus some is good. When and where possible, I always like to add 2 construction holes. Why, you might ask? Does anybody have an idea? Radar knows this stuff. Because I don't have to side mill it, if I can set up the construction holes on the vise or on a right angle plate or whatever it might be, I'm just going to make these equal a minute. The what?
Now you don't need a sign plate in the tank.
Or side mill it. If possible, I like side milling because it's
But if
CNC
your holes-
accurate.
So if you have green holes in the end of that, right? The green holes are gonna be more accurate now.
Agreed. Yeah. So these are double holes, right? So if we call a hole call out, and they should be, I should change my hole call out standard, but it should say 2 times quarter-inch or slip. And in our annotations,
But the ones in the other view that got deleted, right? If they had double holes in that view,
well, even tapped holes that pretend they still have to be accurate, right?
so yeah, we've got
Right.
holes that they're not straight up and down or anything like that, here's good.
Right. So
Tap holes have a little bit of,
yep. So the main benefit here is, let's say I call out my ordinates. Even in an email, I did a project for a customer a while ago, and they wanted to build everything in an email because they didn't believe in CNCs. No joke. All right, fine, no problem. We will give you a print package that you can make in an email. Even in an email, you can make this fairly easily, right? You can put 2 holes very accurately in an XYZ plane and drill them and tap them, or drill them and ream them, no problem. Well then, I could, and we'll try to simulate this in CAD. I can then put this and try to rotate this a little bit. Pretend that's horizontal. I can then on a right angle plate, or if this isn't so long, right angle block, or if this isn't so long, I could do like 12 jaws on a vise or something. You could then take this, set it down, make sure those dowels are set down on that flat parallel surface, clamp it down, C-clamp it, whatever you need to do. And now, when you do that, this angle isn't cut yet. So pretend that you've still got this here. And that are perfect. So pretend you still got that material. I can now cut down and end mill, right, side mill down to that angle. And the way that we accomplish that is, to be nice, we give them a dimension from our angle to the top of our dowel. So they can come down on Z, touch off the end mill on top of that dowel, move up, and they can just buzz cut that entire top off. Now for the placement of these holes, I want to do my 3D rotate view, and then take my center line and drop a center line in those dowels, exit my 3D rotate view, and then I can take a ordinate dimension and very precisely from those dowels decide where that's going to be. So again, I can edge find off my dowel, find out where the middle is, go to the middle, and then that's my 0 ordinate. Now I can very accurately put those dowel holes in. No sign plate needed, no machinist math needed. Again, I have nothing against like the guys cutting the stock on the saw or the machinist using math, having a calculator, having a sign block. But if the computer can do it for me, if I can create a more accurate part for less money, with greater ease, have a better relationship with the machinist, and not have all these possibilities for error, the better off everyone's going to be. So adding 2 holes, if acceptable in the design, which it's not always, but if acceptable in the design, adding these 2 holes, whether it's CNC or manual mill, will reduce the cost and increase the quality of that particular detail. Any questions or comments on that? Yes? No? Wow. Okay. Well, I think time is up. Other people are here. I appreciate you guys staying through the 4th installment of machine design and watching me as I figure it out. Maybe next time, I don't know if I have anything else fun. Yeah, okay. We'll leave it on that slide. Maybe next time we'll talk about maybe light curtains, or we might add a pneumatic cylinder, or do a gripper, or 2-in anti-tie down, or something else fun like that. We'll see where it goes. Maybe my friend will be back and he'll tell me what the design's supposed to do. Thank you very much.